Hi, this is ASIC, FPGA, and DDR rail power design through PMBus power supplies. And here we're going to talk about how we can implement PMBus in manufacturing and what are some of the common PMBus usage examples. So how can we implement PMBus in manufacturing? Well, the good news is the TI Fusion GUI Digital Power Designer also has a manufacturing tool. So first, we use the Fusion configuration tool to select the settings for the rails, the voltage regulators on the board. Once we have selected the settings, we export the settings to a file, and then we load this configuration file into the manufacturing GUI. The PMBus programmer script is very easy. It's a device-neutral way to specify the programming steps required to write and verify the values in the IC NVM, non-volatile memory. Equipment vendors only need to do programming algorithm development one time to cover all TPS devices that will use this format. The script flow goes like this. First, you verify the correct part present via the device code PMBus command read. Then, you write the configuration to the volatile memory via PMBus. Then, you execute PMBus store all command to save this configuration from the volatile memory to the non-volatile memory. Then, you reset the power to the device. And finally, you read back the configuration via PMBus to confirm the values are correct. This takes into account device timing requirements, and the text file is offered in a comma-separated value CSV format. And here's an example below. On the left, you will see all the write commands that you use to write the commands and their values into the IC. In this case, the IC we use is our dual buck controller, also configurable as a dual phase controller, TPS 40422. So first, you read the value of the device to make sure you're writing into the correct device, and then you start writing the commands. First, you write whatever information you want to save into the user scratch pad. It could be project name, project revision, project phase, etc. Then you write the manufacturer 21 command, in this case, to enable the analog to digital converter of that buck controller to monitor output voltage, current, and temperature, and you also program the dead time between channel 1 and channel 2 gate drivers. Then you write the on-off configuration mode. In this case, we have selected always converting. In other words, when the power supply is present to the IC can start converting. Then we write the I-out cal gain value to calibrate out any gain errors from the output current monitoring that is offered by the IC. Finally, you store this configuration to the data flash by executing the store user all command. Then you reset the power to the device and you read back the values that you wrote into it, such as the user scratch pad, manufacturer 21 for the ADC and the channel 1 and channel 2 dead time, the on-off configuration value, as well as the I-out cal gain correction value. Finally, after you verify that the values are correct, you end the script and the manufacturing script is ready for use. A lot of customers have JTAG ports, and we have gotten questions about using the JTAG port to program through PMBus. Our sequencers offer that capability, but our TPS 54K buck converters and TPS 40K controllers do not offer that capability yet. In the meantime, you can use a JTAG to PMBus adapter. Basically, this adapter accepts a JTAG interface communication in and has load devices like CPUs toggle the clock and data lines on our PMBus devices to emulate I2C communication as described in a JTAG script. Keep in mind, though, that our voltage regulator devices at this time support by default SMBus PMBus communication. So, what are some of the PMBus usage examples? First, you can obviously use PMBus to configure your power supply in the lab. This offers fast and easy evaluation, and you don't have to use any external components to program the power supplies or the current limit settings, the under voltage lockout settings, the soft start or switching frequency settings. All that is done through PMBus. You can also use PMBus in the factory. You customize your board and the power system on your board during manufacturing using the manufacturing automated test equipment that you see here. You can also use PMBus in a system and develop a real-time dashboard to monitor, optimize, and manage faults. This is done by some of our customers, and they use PMBus for remote monitoring of their systems out in the field. TI offers PMBus DC to DC conversion end-to-end. Here you see a 48 to point of load PMBus system. It is comprised of a 48 volt hot swap controller with PMBus to monitor and report input voltage and input current, a 48 volt isolated PWM controller in a full bridge configuration, the UCD3138, and 12 volt input PMBus point of load controllers, in this case the TPS40422 with an external TI power block. For more resources, please visit these links below. Tune in for the next segment that talks about what PMBus telemetry does and what types of PMBus power supply ICs TI offers.